don't we find the derivative first? So f prime of x, and that is limit of h approaching 0 of f of x plus h minus f of xa over h. Now, you don't have to give me this line anymore because I relieved you from this burden. And starting with this line is where you need to give it to me, x plus h minus 1 over x over h, like that, a. Okay, then that is equal to, what is the tactic whenever you see fraction? You find the common denominator, a. And then x minus x plus h, like this. And then this dividing by h, we can just multiply the reciprocal. Now, h approaching 0, and x is canceled, so you have this h. By the way, don't be distributing the denominator. And h cancels, so limit of h approaching 0 of -1 over, like that, right? Now, here's the thing. You may skip to this line. You don't have to show me this middle line, okay? It's okay. But when you cut corners, do it at your own risk. Here's the most common mistake, right? Because you're doing, okay, cancel, and you forgot the negative sign to be distributed. You know what I'm saying? Now remember, it's 1 out of 9. That one tiny negative sign is equivalent to your one multiple choice questions. So let's not lose those precious points like that. You get it? So be very careful. This is one of the most common mistakes. So I wanted to point that out. So it's this way. Now we take the limit, meaning you don't write limit anymore because you have taken the limit. H is 0 now. So you have -1 over x squared. And for our future purpose, this is also known as negative x to the negative second power a. Now, then we need a slope, so we substitute 2. Because from the problem, it tells you at 2, x is equal to 2. That means it's -1/4. Now come over here, point slope form. And I will assume you know how to do point slope form and convert it into slope at intercept form like that. And lo and behold, this thing looks like that equation right there. You get it? Okay. Any questions so far? I'm gonna get to, okay, some notations. This notation is weird. Okay. If I write this, I'm gonna do this with blue. If I write this, what does it mean? It means the derivative. Okay. Now, Newton called this thing f prime of x, the derivative of f, right? Remember there was another mathematician who figured this out about at the same time. His name is Leibniz. Let's remember, original definition is this. Delta y over delta x, isn't it? And Leibniz called this thing dy over dx. You see, when we say this d, that's infinitely small limit and delta together. Good? Okay, now, and this is where it gets weird. What? You can separate that? Yeah, wait. When I thought you said this, that this means just dx, delta x, one term instead of two, right? But yeah, he did it, so blame him. When it comes to y, he separates it. So this is now derivative operator. So whenever you see that, and then we can actually write this way as well. So if I say something like this, it means take a derivative of sine x. You get it? So that's our notation now. Okay, then What's the second derivative? Derivative of a derivative. Newton, of course, called it f double prime of x. What did Leibniz call it? Well, let's do it. So it's derivative of derivative. You get it? Which, of course, becomes, you can separate it again, like that. Then this is where it gets really weird. What? And then, watch this. What? I know, blame Leibniz, it's not me. So this thingy is one term, dx, but this d is d times y. Oh, why? Why? Well, just accept it, swallow it, okay? It is what it is. We didn't have a say in this when he decided. Okay? Then, oh, guess what? Third derivative is this, right? Fourths, fifths. Is that fifth derivative? There's also a Chinese version. Okay, let's not do that, right? It's not that. This is really fifth derivative, parenthesis. Right, of x, and then Leibniz did this. You know what I'm saying? Okay, so when you see that open parenthesis, that's Newton's notation of fifth derivative, and Leibniz did it like that. Okay, it's just a notation, so get over it. Okay, now we'll do the next prompt, which is this. Okay, derivative of x cubed. Shall we do it? Okay, so once again, f prime of x is equal to limit of h approaching 0 of f of x plus h minus f of x, the line you don't have to write. This is the beginning of your actual work. Like that, eh? Now that is equal to limit h approaching 0. You know how to expand this 13318? Too much algebra? Yes, no, maybe. So this thingy cancels that thingy, and we can cancel h. So some of you, let's not lose points like this again. Parenthesis. Too much algebra? Parenthesis equivalent to one multiple choice penalty, big penalty. Now h dies, so this is 3x squared. How about that? Now f prime of x by definition is limit of h approaching 0 of f of x minus, see, first mistake already, right? F of x plus h minus f of x. My computer is slow, it's laggy. Okay, now we substitute. So we have limit h approaching 0 of, we'll have square root x plus h plus 3 over x plus h minus square root x plus 3 over x over h. And now here's our problem. See, you have done with square root last year, and you have done it's like 1 over x kind of thing. But have you ever done combination of the two? How do you deal with something like this, right? Here's a nice trick. They're really the two separate problems. Watch this. Oh, okay, it was plus. You get it? Too much algebra? Okay, I just separated the two. Now we can do this separately then. What is the trick when we have radicals? We multiply. I'm gonna do this. Oh, this is actually pretty good. We multiply by conjugate looking thingy, right? Tell me you have seen this before, this technique? Okay. So what we have here is difference of the square x plus h minus x over, and whenever we do this, we do not ever distribute this. Leave it like that. Second one is now we find the common denominator, eh? So that common denominator is this. So we have 3x minus 3x plus 3h, eh? And then we can multiply h as a reciprocal like that. Let's cancel stuff. So this thingy cancels that thingy, and then h cancels. And then this thingy cancels that thingy, and then those h cancels, right? So what we have left is limit h approaching 0 of, what we have is 1 over square root of x plus h plus square root x, and then here is plus 1 over, not 1, 3 over x plus h times x. You with me? Now h dies, so we drop the limit symbol. And then this thing, of course, is, oh, I just said I dropped the limit symbol and I wrote limit. This thing is square root x plus square root x, which is this, right? And then second thing is something went wrong. I think I made a most common mistake. And most common mistake is this is minus, right? And then if you watch the other video, I tell you not to screw up like that. If you cut corners and do this in one step, that minus, you have to distribute that minus sign. You know what I'm saying? Because when you find the common denominator over here, this multiplies to -3, so there's a minus. You get it? Okay, great. Matthew got kicked out. Okay. Now, so this is minus. This is minus as well. So 3 over and x squared. And for our purpose later, this is same as 2x, 1 over 2x to the -1/2 power. And this is same as minus 3x -2. Right? This is leading to the power rule, as you well kind of know it already, but at least heard about it, the shortcut, which is coming like in a day or two. Any questions so far? What's scary is we have to find the derivative of this now. Oh boy, let's suck it up and do it. So f double prime of x is equal to limit of h approaching 0 of f prime of x plus h minus f prime of x over h. Exactly same idea, you just do it twice. Now this thingy, oh my god, this is hideous. Minus parenthesis this is what we are looking at, huh? No, it's too hard. Do I have to do it? Suck it up and do it. So watch this. Let's combine the like terms, if you will. Do you agree that this is this one, and then minus, I'll do minus, and then parenthesis, no, it's okay. 3 over x plus h squared plus, this one is plus 3 over x squared. I'm gonna do it like this and put that thingy in between and make that minus. How about that? Still the same thing? Too much algebra? Okay. And then, now, we know how to handle the second part. We just find the common denominator and do it. How do you do this? If it's radical, we multiply the conjugate looking thingy. If it's fraction, then we find the common denominator. This is a combination of the two. So what are we supposed to do? Which one do we do? We do both techniques. Okay, that's great. Which one do we do first? Any idea? I only know this from experience because I've done it both ways in different years. Both ways are about the same equal amount of length, but common denominator first is slightly shorter, easier algebra. The other way works too. So I'm gonna do that. You can do whatever the hell way you wanna do. They both work. I've done it both ways. Okay, so finding a common denominator, which of course is this, right? So we multiply this up. So we have square root x minus square root of x plus h, like that. We good? Okay. Now minus this one. Oh, I forgot. H. I have to multiply by h. 1 over h, like that. And minus this one, the common denominator, of course, is this. And then we have 3. I'm going to factor out that 3 out here, common factor. Okay. And then I'm going to do the rest. Minus x plus h squared. Still with me? Okay. And then I multiply the conjugate looking thingy. Watch this magic, right? And that conjugate looking thingy is this. Too long. You can imagine this part, by the way. You really don't have to show me, but I'm just trying to explain it. Where did that square come from? I can't find where that thing belongs anymore. Whatever, right? Why did that thing turn into red? Okay, don't have time to investigate, so let's just get it over with. So this becomes x minus x plus h on the numerator, and the denominator is super long. Like that, and don't multiply, don't distribute, don't even think about it. Minus 3, and then this thingy, you'll have this. Okay, I can just stick that thingy here. Okay, I think I lost that h, so let's put it right there. And then x squared cancels, so do you have negative 2xh minus h squared? Too much algebra? Nay? Okay, cancel h. You see why I didn't want to skip this line? So h approaching 0 of x cancels. Okay, let's be careful. If you cancel like this cancels that, and this cancels that. And then very important, -1. You get it? That's the most common mistake. You can do this, except do it at your own risk. Like that, minus 3, and this gives you negative 2x minus h. You with me? And then this h cancels. Oops, I'm dumb. I already canceled it and I wrote that h again. X minus h. I already canceled the h. Good. Okay, now h dies. So when h dies, finally we get this. -1 over, this thing is 2 times x, right? This and this gives you x. And this thingy gives you 2 square root x. Okay, and then minus, and we get 6x, h died, and we have x to the 4th. You with me? One of the x cancels, so we have -1 over 4x root x minus 6 over x cubed. And in order to develop the power rule, this is a 1.5 power, right? Too much algebra? And then minus 6x -3. Well, you do it very carefully. I'm gonna put this axis about there. Okay. So we have, this is f, and this is f prime. Okay. Now let's first start with, so f prime is the derivative of f, right? Let's start with the obvious places. Right there, that looks flat to you when x is 1. So at 1, let's say this is about 1. It plots right there. You get it? Oh, that's flat right there as well, and x is not quite -2. So 1, 2, about there. You know what I'm saying? Okay. Now then, let's go somewhere in the, let's try to guesstimate this right there. What does that slope look like? Does that look about same as that to you? So if I were to connect this piece to this piece, that looks like about -2 to you, right? So at the steepest point, that's the most negative, biggest negative slope there is. That should be around -1/2 and -2-ish. So what we are looking at is 1, 2, that's -2. And it has to be about there, right? So far, so good? Okay, now let's see. Oh, right there. That looks steeper. Because if you're looking at, you know what I'm saying? That, let's say this is about 3. So at 2, we are looking at 1, 2, 3. About there. I mean, it's like about, it's not exact. This is more of an art than a science. And then that looks about the same amount of slope at -3. So we have 3 about there. And then we connect this, and then you notice that this slope changes gradually, right? No pointy, no sudden change. So that you think this will be gradual curve. Oh yeah, smooth, 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 smooth. And making sure that the vertex is not pointy, because that triggers very painful memory to Mr. Kim. How about that? That still looks pointy. Hold on. I can't handle this pointy. Okay, better. So much better. Parabola looking thingy. And that kind of makes sense because this looks somewhat like a cubic function, and the derivative yesterday's example, derivative of cube was quadratic function. Yeah! Now that makes sense now, doesn't it? So that's how you do that one. Okay. Now, well then, let's look at number 30. What do they want in number 30? You have a distance. I have to read. We have a river, blah, 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 blah. And we have this. Sketch this. And okay. Sketching part, I believe I use the Microsoft Excel. Because otherwise it's pain in the butt. Okay. And you guys can use the regression thing on your calculator to do it, but like nobody wants to do a hand sketch of something like this. It's like, ew. Okay, and then approximate the derivative. So I'm going to explain how I approximated it. This point right here is this over this, this minus this over this minus this. Kind of get it? Y2 minus Y1 over X2 minus X1. And then this thing is this one minus this over this one minus this, and I just computed this and plotted that, and that turns out to be like this. How about that? Somebody got kicked out again. Okay, so that is part B. Average change of elevation is called the gradient, right? What is the measure? Okay, so average change is the rate, so it's like feet per mile, right? Because one is a feet and the other is mile on your, see if you look at the book. Oh, it's tiny, but you see this is feet. I can do that for you. You see this is feet and this is mile. It's a stupid unit, but so it's a feet per mile. You know what I'm saying? Okay, so that's C. And D in this problem, what unit of the measure would be a feet per mile again. This is I'm really sorry I assigned this dumb problem. Why? Every year I say to myself, okay, next year I'm gonna take that one out from homework list. And then I forget the next year. So this keeps happening, and it's been happening for the last 15 years. Okay, next year. Note to self, next year, video. If you ever watch this video of yourself, take this one out. The most dangerous section. Most dangerous section would be there, right? Like bang, right? It's just sudden drop or whatever. Okay, this part right here, because that represents the steepest drop. How about that? That's all I'm gonna say about this. This is stupid. It's like more of a data science than math, which is totally inferior subject. Okay. Okay, now there's that. 32. And you wanted to do the right derivative? You want me to do the left derivative as well?
I think just the right's good.
Just the right? Does anybody want left? Now's the time. So left is pretty straightforward because it's part of the cube, right? So we'll do the right derivative, which I have it cut off here, so I'll continue with this. So h approaching 0 slightly from the right. Like that, eh? Okay, then that's what you are. Don't write this down. I'm going to intentionally screw up. So what we have is 3x. So what we do is 1 plus h, or 3 here, minus, and 3x, so we put 1, 3 over h, right? That's what you're thinking. Don't write this, because it's not right. It's your job to catch the mistake. So 3 is canceled, so you have h over h, right? So you have 1. Oh, wait, 3 is canceled, and then you have 3h over h, so you have 3. And then you're thinking, wow, this 3 is equal to that 3. So right derivative, left derivative, they agree. So what's wrong with it? And it looks right too, because slope at this end is 3, looks 3, and it looks parallel to that line. That's 3. So why not? Somebody catch this mistake, and this has to do with one of your FRQ problem on your previous test. You fell into this trap, Ethan.
When you did that, you put in -3 because you were plugging 1 into f of x at 3x, but it should be 1 cubed, which is -1 because that's what f of x is at 1.
Equal sign only belongs to one of them. You know what I'm saying? So that was the mistake. Cannot really use 3 here. I'm supposed to use 1. You know what I'm saying? Graphically, this point belongs right there, and this is open circle. And you might say, why don't we fill that circle? Well, if you do, then it fails the vertical line test, so it's not even a function. So it's like, forget differentiation. You know what I'm saying? Okay, so now let's fix this. So this does not really cancel after all, right? So we have 2 plus 3h, eh? Say yes. Say yes.
Yes. Yes.
Yes. Thank you very much. And then if you take this limit, h approach, denominator approaches 0 and numerator is kind of like this, right? Which is not a proper math, so we shouldn't write it. So this thing approaches infinity. How about that? I'm going to graphically show you what this thing does, because I have just such a thing. Open calculus. I have piecewise function. Okay. Oh, it's almost the same problem, right? Except I need to change this to 3. Okay, now let's take a look at this thing. This is a breaking point. Now this is what we have, isn't it? I know it does this. Isn't it amazing? I really sometimes amaze myself. And then that dot belongs right there. So far so good. So if we are trying to draw a tangent line, this is what's going to happen. That point is there. So if you draw it this side, and then let this side approach, then it's going to go up and give you a slope of 3. You know what I'm saying? But if you go to the other side, this happens. Because notice that this point is still here. So we're trying to connect it to that side. And this thing will stand up. So you get infinity. How about that? That's amazing, isn't it? Yeah. Okay, so that's graphically what's going on. Okay, now, then, any more questions? Move on. Okay, this one looks very similar now, doesn't it? Okay, oh, it's got A through H. Can I just do few, not all of it? Whose question is this?
Oh, yeah. My question was just about part F.
F. Does the definite left-hand derivative of f at x is equal to 1 exist? Okay, left-hand.
Oh, wait, never mind. I thought that's for number 44. This wasn't my question. Okay. Sorry, my bad.
Whose question is number 42?
It's actually mine. So yeah, I'm just a little bit confused over the concepts involved here. So for example, E and H, like what is the difference between the two, and what is the difference in methods of finding the two?
E and H, F prime, oh.
Sorry, I'm really confused about this.
E and H. E is a one-sided derivative. And H is the two-sided. So left side, if you put this one, wait. Oh, I see. If you find the derivative function, it's asking you for the continuity. Is f prime continuous? because the limit versus the value. You get it? So this is a definition of continuity, but not continuity for f, but if they are asking if f prime itself is continuous. So you have to almost get another function and do it. You get it? No.
Okay, but for the derivative, we can just find its limit. We have to use like as x approaches h from negative and positive sides.
So in order for this to work, you have to figure out left derivative and right. Oh, I see. This thingy, yeah, left derivative and right derivative approaching 1. And then this thing, if they both agree to each other, then this thing holds. You get it? So I think they mean almost about the same thing. There's a subtle difference, but it's, I guess, almost the same thing.
Oh, okay. So is the derivative just like another function where like one limit can exist at one point, but it's not continuous?
For example, if f is equal to that function, f prime, I think we have done this before, will turn out to be this. You know what I'm saying? And we want to see if this thing is continuous at 1. And turns out it is, right? By looking at it. Yeah. It's that kind of question.
Oh, okay. Yeah, so that's for E, right?
Yeah.
And I just want to make sure, like, so if we want to do H, so like we need to use a different method, and the methods we learn about approaching H from different sides.
F prime of 1. I'm getting confused about the question itself. Does it exist?
I'm confused as well.
Looks like it does exist, and answer says it does not exist, so I'm really confused now, right?
I don't know.
Oh, it's the same issue. The reason it doesn't exist, although it looks as it exists, is exactly the same thing. If it's discontinuous right here, then we have the same issue. The tangent line will stand up. And then if you plug in 1 here, it becomes 1. If you plug in 1 here, that's like left limit, right limit, it becomes 2. So this is a problem with discontinuity, which is one of the topics in today's lesson. It's not differentiable function is not differentiable at discontinuity, although if you do this, it looks like it connects. They don't.
But Mr. Kim, I don't understand, like, but the limit does exist. So if it's a jump continuity, shouldn't the limit also not exist?
Limit does not exist either, but this is a limit of the derivative.
Right. So if the derivative itself doesn't exist, and if like the reason doesn't exist.
Let me just work this out for you, because like verbally explaining math, I don't think it's that productive. So let me just do it. You understand this part? How I got this? Mm-hmm. Right? Because you just take a derivative and derivative with a difference quotient, and you end up with this, right? So what you see here is if you take a limit of f prime of x as x approaching 1 from the left-hand side, you get 2. And then limit of f prime of x, oh, this computer is really laggy, from the right-hand side, you get also 2, right? So that means, of course, limit exists, right? X approaching 1 is equal to 2, right? But then does the derivative exist? Well, in order to figure out this, right, f prime of 1, you cannot just plug it in here because this thing is not defined. There's a hole, and you will about to see why there's a hole. That's more like a spike, but in high school calculus or even freshman college calculus, it doesn't exist. It's more like a delta function if you ever go to graduate school. Okay, forget what I just said. No delta function. Don't worry about that. Never. No delta function on your test ever, okay? Then we have to do this. Limit. This computer doesn't work anymore. I'm going to have to exit this and come back to it. And then for some reason, okay. Looks like today's lesson, you'll have to watch the video. Okay, let's see if this works. Limit of h approaching 0 of f of 1 plus h minus f of 1. And let me just pick the size that doesn't work. So it's the right-hand side that's not going to work. So make it slightly positive. Left-hand side will be fine. It'll give you 2. Okay? Let's do this. And then f of 1 plus h, we are supposed to use this function right there, right? So 2 plus 2h. Good. Minus f of 1, we are supposed to use this function right here. So it's 1. It's exactly same issue as the previous problem. And do you see that thingy is limit of h approaching 0 of 1 plus 2h over h, and you get infinity. So if we have to sketch this function, it's going to look like this. I'm going to put them here. It just looks like 2 everywhere, right? Where 2 and 2x. So this function will look like this. And this is that 1. You know what I'm saying? This is 2. So it exists everywhere except at this point there's a hole because it's infinity there. And so it's like, it's really an infinite height of a spike. That's what delta function is, but then you're not supposed to know what delta function until graduate school. So yeah.
Okay, thank you so much, Mr.
Yeah, I know that I was confused about that too, but I'm glad that you asked, so we get to the bottom of this. So f prime of 1 is not same as the limit of these guys. Okay. Okay. Next question. Oh, next question. I have next question. This one, right? 44. Which limit do you want to see? Oh, we are supposed to find the k.
Finding
right?
k, yeah.
Okay, so we have to do both, I guess, huh? Might as well just do both and then call it a day, right? Yeah, let's do that. Totally inverted classroom, right? How do you like it? This is what inverted classroom is, except that inversion happens in other period. Okay. So let's do a left derivative. So left, with lack of better notation, I'm just writing it L. So we have f of 1 plus h minus f of 1 over h. And this one is h approaching 0. F of 1, if it's slightly less, then we are supposed to use this function for both, right? X cubed function. Okay. So we have 1 plus h cubed minus 1 cubed over h. And that is, you all know how to do binomial expansion, eh? 1, 3, 3, 1.
Yeah.
Like that. And then let's start canceling. I think we can do this confidently and cut some corners.
Is it supposed to be h cubed? At
Yes.
Okay.
Yes. Let's try to see if you're paying any attention. Of course, and only one guy was. Okay. And then this h is die 0, and that's my notation for limit. You can use it. Right, 3, as we expected. Now we'll do the right-hand side. So the right-hand side is limit of h approaching 0 from the right-hand side. So h here is slightly positive. did I write h approaching infinity right there? And nobody was paying attention? Ah, you kids, pay attention. 3x plus h. So we are supposed to use 3, 1 plus h plus 3x plus k, right? Yeah, k. Right? But minus f of 1 is still 1 because that equal sign, once again, belongs here. So we are supposed to use this function to plug in 1. You know what I'm saying? Okay. And this is a big deal in continuity, like differentiability. If the derivative exists, in order for the derivative to exist, it needs to be a continuous function. And you know that in math, converse is not true, right? So if you have if then this way, the other way is not necessarily true, right? Okay. If I say idiots will never get an A in calculus, half of you will be, oh, what are you saying? Well, converse is true, not true. So if you're offended by that statement, what are you saying? You know what I'm saying? Okay. So this becomes 3. Let's just cut some corners. So 2 plus 3h plus k. Say yes. Okay.
Yes.
Now, if you take the limit, this will approach infinity, and that's a problem, right? Unless, of course, this k and this 2 cancels out, then it'll give you 3. Then we are good. You know what I'm saying? So I'm gonna say it this way. Piecewise function. It is equal to k if it is equal to 3 if k is equal to -2, and then infinity if k is not equal to -2. How about that? So I think we found the condition k needs to be -2 in order for this thing to be differentiable. How about that? You get it?
Yep.
Yeah,
Thank you.
beautiful,
Yeah.
beautiful problem. Okay. Yeah, I was not as clear in the Dropbox note. Maybe I should save this. I like this thing better. Okay. Now, any other questions? Nay? Are we all good? Should we? Okay, I'm gonna stop the video right there.
Wait, Mr. Kim.
Yes.
It's for the piecewise, isn't it 3 when k is not equal to -2 and infinity when k is? Wait, can you explain the piecewise one more time?
Okay. Suppose this k is equal to -2. I'm gonna write it here. Limit of 2 plus 3h minus 2.
Mm-hmm.
And that gives you 3, right? Because 2's cancel.
Yeah.
And h is cancel. So when k is equal to -2, we're good. When k is not equal to -2, then we are in trouble. You know what I'm saying?
Oh, yeah.
Okay, technically I shouldn't say infinity because if this k is if less than -2, then we get negative number, right? So, okay, I shouldn't say infinity, plus or minus infinity. How about that? Right? It's some kind of infinity. It's divergent. That's all I'm saying here. How about that?
Okay, thank you.